I hit record. Do you want to do it?
I'm
Alan?
recording. Yeah, you can stop yours.
So do I begin? It's safe? I'm good?
You're good?
Cool. So this next one, which is question 19. 19, there we go. So question's asking, you have isolated an element that in its neutral state has a mass of 32.06 grams per mole and it has a total of 16 electrons. What's its identity? Kind of simple, right? So one of the first things that I always look at when it comes to elements is it charged? Like, is it an ion or is it neutral or is it an isotope? You know, just those basic things. So can anyone remind me what type of element we have here? Like, is it in its neutral state or what's going on?
It says it's in its neutral.
Yeah, it's in its neutral state, right? Okay, so when an element's in its neutral state, what does that have to do with like its protons, neutrons, or electrons?
They balance each other out, so you would have the same number of protons and electrons. So you don't have a
Okay.
charge.
So we have electrons, if I'm not mistaken. So if we have the number of electrons, it's neutral. So what would be the number of protons we have? E. I don't know how to spell neutral.
AL.
AL, yeah, I figured. Sorry, it's been a while since I've had to do English. But yeah, so what do the protons and electrons and I guess neutrons have to do with the element being in a neutral state? I'll give you a hint, it has something to do with electrons.
So we said it's neutral. We said neutral means we have the same number of protons as we do electrons.
I didn't know. I was actually trying to get them to say that, but okay.
Oh, I'm sorry.
Nah, it's too late. Okay, so like Sophia just said, so the electrons have the same amount of protons here, right? So how many electrons do we have here? Anybody know?
16.
16, right? So if we have 16 electrons, how many protons do we have?
16.
Okay, and so with that, is there anything on the periodic table that we use to identify protons with? The atomic number, right? So what element has an atomic number of 16?
Sulfur.
Okay, and does sulfur have a atomic mass of 32.06? Whatever.
Yes.
Well, boom, there's your answer. So your answer is going to be D. Huh, that wasn't too bad. So any questions on how we found sulfur? I'll take that as a no. All right, so our next question number 20. It asks, a sample of uranium was identified to have 92 protons, 92 electrons, and 143 neutrons. So, and it's asking for molar mass. So how would we find molar mass when it comes to an element? I'm like so concentrated right now. Okay, so how many, So how do we find molar mass, guys? Do we add something? Do we subtract something? Multiply? Leave something out? I know at least one of you guys know how to get atomic mass. So nobody knows what we need to, huh?
Does anybody know what the heavy part of an atom is?
Here's a hint. It's in the nucleus.
Isn't it the proton? Because the neutron has like no mass.
Does it
Does
have no mass?
Ooh, thanks.
Very
Okay, so we know the proton weighs something. Does the electron weigh something? Is the electron small or big?
smaller than a proton. Right?
Okay, so since it's smaller than a proton, that means that, well, I mean, in this case, it has like basically no weight, like it's really, really small. So we don't need this one. What about neutrons? Do they weigh close to the same amount as a proton? Do they weigh more? Do they weigh less? What do you guys think? So we know the 90, dang it. So we know the 92 from the protons is going to be included in this. So what else do we include for the atomic mass?
Hint, hint, it's one of 3 numbers on the whiteboard.
Yeah, and we already crossed out one of them. So
143 neutron.
yeah, so we'll use the protons and the neutrons because they make up the mass of an atom. So what would be the atomic mass of uranium here?
235 grams per.
Beautiful. So 235 grams per mole. And that gives us answer A for question 20. So, I mean, we just talked about this, but you know, it's good to go over it again just in case. So for 21, what makes up the mass of a element or of an atom? We just did it, guys.
We just used them. What did we use to solve number 20?
A and C. I mean, well, proton.
Yeah, A and C, which is protons and neutrons, right? So there you go. That's D. Now, 22. A pure sample of a common element has a mass of 16.84 grams and contains 1.55 times 10 to the 23rd atoms. What is the identity of this element? So how are we going to figure out how to find, like, how are we going to figure out this element? Oh, that's the wrong one. 16.43. 8. So we have 16.84 grams per mole. Or sorry, 16.84 grams, and we have 1.55 times 10 to 23rd. So using this, or what can we use to figure out what element we have?
So we could use Avogadro's number to find out how many moles we have.
Beautiful. So 1.55 times 10 to the 23rd atoms. Now from there, oh yeah, like you said, we use Avogadro's numbers. So is the Avogadro's number going to be on the top or the bottom?
On the bottom.
There we go. So 6.022 times 10 to the 26th, if I'm not mistaken, 23rd. Or atoms per mole. Okay, so how many moles do we have?
Point 0.25.
0.25, right? So 0.25 moles. So we have 0.25 moles, and we have the mass, which is 16.84. So how are we going to get the molar mass to figure out what element we're talking about? Oh, I just said it, but like, what are we going to do next?
Divide your grams by your moles to give you grams.
All right, nice. So 16.84 divided by 0.25 gives us, that's a 5.
$67.36.
67.36. So what element is the closest to this molar mass or atomic mass? I'm sorry?
Zinc.
Yeah, it'll be zinc then, right? So your answer for 22 will be A. Ooh. Any questions so far on what we've been doing? Everyone all good? All right. So the next,
Jeremiah, before we
what?
go on, so we're hitting the last 40 minutes of the review session. So we thought we'd let you guys request problems. Is there any topic that you guys want to see problems for? Or do you guys just want to keep going? Because at 12:30 we're gonna cut the review session. Send request in the chat or unmute yourself.
Yeah, we can do anything. Oh, just so you guys know, the topics that I would recommend you guys put a lot of focus in is nomenclature, conversion, basic algebra, and stoichiometry.
And
If you
balance
guys,
equation.
And balancing equations. Yeah.
well, that's stoichiometry. But yeah, like if you're able to do those, then you'll have a rough
Easy breezy,
rough
beautiful.
estimate. Pretty much, you'll be good for the final.
Okay, we do number 43.
43.
Number 43.
Yeah. Oh, I got you.
Go for it.
Okay.
Do you want me to stop
43.
sharing?
Yeah, sure. I'll share my board.
I get.
Share. We're on page 305, by the way. Let me see if it'll make this bigger. Okay, it says, you're in a lab and are asked to add 75 milliliters of a 1.5 molar sulfuric acid solution to your experiment. However, there's only a stock solution of 5.0 molar sulfuric acid. How much water would you need to add to your final solution to obtain a molarity of 1.5? So first of all, we want 75 milliliters of 1.5 molar solution of sulfuric acid. So that's HSO4, H2SO4? Yes? I don't see the chat. What's going on? Nomenclature, balancing equations, conversions. Okay. H2SO4? Yes? Any objections? I'm winging it here. Okay. And then, but we only have 5.0 molar of solution. Yes? So we're going to dilute or add water to decrease the molarity. So what do we know about molarity? What is this big M really, like the smaller units, I guess?
Moles
within
per liter.
molarity? Moles per liter, right? So volume in liters, very important, right? So if we have 5.0 molar, what can we say about the moles per liter in the solution?
Can you repeat the question again, really?
Yeah, so if we know that molar, the big M, right, stands for moles per liter, what can we say about the 5 molar? Can we rewrite that in moles per liter? So if I were to ask you how many, in this 5.0 molar solution, how many moles are there in every 1 liter of water, what would you tell me?
5.
Yeah, right? So we have 5.0 moles in 1 liter, right? So that's what we have. Now, if we go back here to what we want, right? 1.5 molar means that we're going to have 1.5 moles in 1 liter, right? And then, but we always want our volume in liters. So what can we do to these milliliters?
Move the decimal place 3 times to
Okay,
the left.
3 times to the left, right? Because we're converting to
Liter.
liters, right? And how many milliliters are in 1 liter? How many milliliters are in 1 liter?
1,000.
1,000, right? So that's where we move the decimal place 3 places. That's what I'm trying to get at. Okay, so then this turns into 0.075 liters, right? So then we have 1.5 moles per 1 liter, that's the molarity, is equal to X moles, right? Because we don't know how many we have, in 0.075 liters. I probably shouldn't have set it up this way, but it's fine. Now we want to solve for X, so what can we do? We want to isolate this, so what can we do?
We multiply by point
Yeah, right?
0.075 liters.
0.075 times 0.075 liters. And then we do the same thing to the other side, right? Basic algebra, 0.075 liters. So then this cancels out. So then we have, why is that doing that? I don't know. We have X moles, right? That's what we're looking for, is equal to 1.5 moles per liter times 0.075 liters. Yes? So then these liters cancel out. So what does that give us for the total X that we're looking for?
Point 112.
I heard 0.112. I didn't do the math. Can anybody confirm?
When I divided 7.5 by 1,000, I got 0.0075.
Wait, you divided what by 1,000?
7.5.
We're not using 7.5. We're using 75
Oh,
milliliters.
that's right. I see. Okay.
Yeah.
My apologies.
So then this would be 1.5 times 0.075. Did anybody else get 0.112?
Yes.
0.1125.
25. Okay, yeah. I want to be more precise. Anyone? No? Okay, what are our units for this?
Moles per liter.
Moles, right? Well, is it per liter though? Because we canceled out these liters. So do we still have liters?
No, sorry, just moles.
No, right? Yeah, so it's just moles. Okay, so now we have how many moles we would need to have 1.5 molar solution in a quantity of 75 milliliters. Yes? And now we want to know how many liters of water we would need to add to this 5 molar solution so that we actually make it this many moles in however many liters of water we need. Yes? Am I going crazy? Am I even doing this right? Okay, anyway. So now we know that we have, what was it? 0.1125 moles. And we have a molarity of 5.0, right? Moles per liter. And we want to find the liter. So is there anything that we can do to find the liters? So we said molarity is equal to moles divided by liters, right? Do we have molarity? Do we have a molarity to work with? Anyone? The ghost of students past?
Yes, we do. It's 5.
We have a molarity. Okay, do we have moles?
Yes.
Okay, and we're solving for L, right? So we don't need one. So what can we do now to solve for L? Or liters, or volume?
M over
What was that? I'm sorry.
we divide the molarity by liters.
Molarity divided by liters. Okay, gives us moles. But then we don't have a number for L, so, or actually we can't even do that because this is being divided. So what is the opposite of division?
Multiplication.
Multiplication, right? So can we really divide on the other side? To get rid of it, I mean. So, okay.
You divide
No.
your moles by your M.
Yeah, you can divide moles by M. If you, or hold on, no, you can't divide. Yes, you can. Moles by N. Moles by M gives you liters, right? If you guys are a little lost, the trick in algebra is you can just switch these, right? But you can also do times L. These cancel out. Moles equals L times M, but we want L, so we divide by M. Cancels out, gives us this. Yes?
Yes.
Okay, so now we have liters, which is what we're looking for, is equal to moles. What are the moles that we're working with?
Point 0.1125.
0.1125. Okay, moles. Divided by what molarity are we working with? 5.0, right? Moles per liter. So that gives us a final answer of
0.0225.
225. And what are the units here?
Milliliters?
Is it milliliters? What are we working with?
Liters?
Oh, sorry, liters.
Liters, right? So then is this an option?
No, so we have to convert it to milliliters.
Okay, so how do we convert it to milliliters?
multiply by 1,000.
Okay, and what does that give us?
$22.5 milliliters.
Okay, so now is this an answer?
Yes, it's B.
B, all right. Does that make sense to everybody? Did I lose you somewhere along the way? I'm sorry. Anybody? We're good? Yes? No? Students of semesters past? Okay, great. That was 43. Any other requests? Oh, there's a chat. What's happening in the chat?
I said LOL.
Oh. Any other requests? I'll stop sharing. Or well, no, you guys aren't showing your faces, so it doesn't matter.
What topics? I feel like we've really only covered like that first bit, but how do you guys feel about the uglier parts? Like
Yeah, like
redox, acid base, enthalpy.
calorimetry.
Yeah.
Let's see it. The last part we went over.
Redox is probably the worst.
Redox is probably rough. I know Redux was a doozy when I took Chem 1 and Chem 2. Lewis structures. I literally finally understood them last week. Look at me. Periodic trends. Anything at all? Everybody's gonna get 100 on this final? I'm proud of you.
We're joking, by the way. Take that with a grain of salt. Ideal gas laws.
Nothing at all? Everybody feels good?
Because
Oh,
I feel
I see a chat. Can we review redox? Ooh, yes. Let's see.
I feel like a good example for that would be the one of the challenge problems, the one that
Oh.
where it had like two. Well, we could do one from here because I know there's like a good example from the challenge problems. From the module it's from.
Oh,
where
the
it
You
one-
had
want to do it, Ellen?
yeah, electrons.
it's the one that had like two different
Two
like,
different masses?
No,
Ooh,
no,
yeah, that
no,
one was
like-
fun. Oh.
well, I don't know what's called the like two it had two reducing and it had two reducing agents and two oxidizing agents, I think, or just one of the other. I can't remember which one. Honestly, just do one from the review. Sorry, I just like that example.
Review. Okay, if you find it, Alan, interrupt me. We can totally do that instead.
Yeah. If we have time.
Should we let Diego do one?
Yeah. Let's find a problem. I can't
Oh,
find
please.
it.
Page 304. That's where they are.
Go for it.
Yes.
Oh,
Hold on, I'm looking
I'm
at the
on page
problem.
305 looking for it.
Page 305?
304.
304.
That's where the redox reactions
So
are.
39, 40, or 41?
Oh, yes, the problems I was going to cover.
Oh, here, I'll stop sharing.
Okay, so there's some about solubility and then redox is 3 or 4. So then go ahead and get started with this. Hopefully my drawing tablet doesn't die halfway. So what problem do you guys think would be best for me to cover? Because 39 is oxidation state, and then it's oxidizing and then reducing agents.
I feel like you should do number 40 because that's like in general just redox.
Yeah,
oxidizing.
do 40, and then when we find an answer, we can keep going and ask them other questions.
Okay. 1 second so I can connect this. Doo-doo-doo-doo.
Oh,
Jonathan.
hey, Jonathan, do you want to do that now while Diego's setting up? When did you pop in? I didn't see you.
I'm just putting it in the chat.
Oh, okay, bet.
That's because I just finished my little review with my own workshop, and one of the students told me this, so that'd be cool.